Assalamu alaikum. Today is the 39th lecture of Software Requirements Engineering, and we are talking about the dynamic modeling of requirements and how we can do using different techniques the dynamic modeling of a system. In the last lecture, we talked about applying state charts to the banking case study. Today we will introduce a new topic in dynamic modeling, and that is the use of interaction diagrams as defined by Unified Modeling Language to capture dynamic behavior and to perform dynamic modeling. Now, we haven't yet introduced what interaction diagrams are. We had briefly alluded to them a couple of lectures ago, but today we'll first introduce what interaction diagrams are, and then we will talk about how we can apply them to capture the dynamic aspects of a system, particularly the banking application that we have taken as a case study. The view of a system of interacting objects is a collaboration, a context-dependent view of objects and their links to each other, together with the flow of messages between objects across data links. This view of the system is captured by the interaction diagrams. There are two kinds of interaction diagrams. First, there are collaboration diagrams, and then the second is sequence diagrams. As the name suggests, the collaboration diagrams basically capture the collaboration that happens among different objects execution time. And it's more focused on the aspects of collaboration among objects. While the sequence diagrams are basically there to capture the sequence of events, the timing constraints and other things. Now, basically, fundamentally, they are the same thing, but the viewpoint is different, that the collaboration diagrams capture the system from the perspective of different objects collaborating with each other to, let's say, implement a use case or to implement some functionality. On the other hand, the sequence diagrams capture the sequence of events that happens between these objects or among these objects to implement that functionality. So fundamentally, they are the same concept, but they're viewed from different angles, and that helps us in understanding the system a little bit better. Interaction diagrams, as I have said, are used to model the dynamic aspects of a system. For the most part, this involves modeling concrete or prototypical instances of classes, interfaces, components, and nodes, along with messages that are dispatched among them, all in the context of a scenario that illustrates a behavior. So the common thing is that you have a number of elements in a system that can be, for example, a class, that can be an interface, that can be a component or a node. And these things are basically UML concepts, and we haven't really introduced or talked about things like interfaces, components, and nodes. But we have talked about classes, and we have talked about objects, and so we can relate to the other elements also. So the concept is that these objects or these elements collaborate with each other to capture the dynamic behavior of the system. And as we have said, that the dynamic behavior of a system is not only very important but also very difficult to capture and to understand. The interaction diagrams may stand alone to visualize, to specify, construct, and to document the dynamics of a particular society of objects. That is the interaction among or collaboration among different objects. Or they may be used to model one particular flow of control of the use case. अब इसके जो दो हिस्से हमने बड़े क्लियरली बताए हैं, एक तो ये कि दो या दो से ज़्यादा ऑब्जेक्ट्स एक सोसाइटी ऑफ ऑब्जेक्ट्स बनाते हैं और उन सोसाइटी ऑफ ऑब्जेक्ट्स की कोलैबोरेशन है आपस में, और दूसरी ये है कि एक यूज़ केस को या एक फंक्शनैलिटी को हम डॉक्यूमेंट कर सकते हैं यूजिंग द इंटरैक्शन डायग्राम्स। अब हम ज़्यादा फॉर्मली देखते हैं कि इंटरैक्शन डायग्राम्स किस किस्म के होते हैं। वी हैव टू टाइप्स ऑफ इंटरैक्शन डायग्राम्स, जैसा कि आप अभी स्क्रीन पे भी देख रहे हैं, सीक्वेंस डायग्राम्स और कोलैबोरेशन डायग्राम्स। अब ये क्या होते हैं? सीक्वेंस डायग्राम इज एन इंटरैक्शन डायग्राम दैट एम्फसाइजेस द टाइम ऑर्डरिंग ऑफ मैसेजेस। तो पहली बात तो ये है कि टाइम के लिहाज से जो ऑर्डरिंग है मैसेजेस की, इवेंट्स की और एक्टिविटीज़, उनको कैप्चर करने के लिए हम सीक्वेंस डायग्राम यूज़ करते हैं, जैसा कि नाम से भी ये काफ़ी वाज़ेह है। ग्राफिकली, a sequence diagram is a table that shows objects arranged along the x-axis and messages ordered in the increasing time along the y-axis. और आगे चल के मैं आपको इसकी डायग्राम भी दिखाऊंगा। तो बेसिकली एक ऐसा टेबल है जिसके एक तरफ ऑब्जेक्ट्स हैं और दूसरी तरफ इंक्रीजिंग टाइम के अंदर मैसेजेस को शो किया गया है, तो एक ग्राफ टाइप चीज़ बन जाती है। On the other hand, we have these collaboration diagrams. ये क्या है? A collaboration diagram is an interaction diagram that emphasizes the structural organization of the object that send and receive messages. तो एक या एक से ज़्यादा ऑब्जेक्ट्स जब एक दूसरे के साथ मिलकर एक स्ट्रक्चर बनाते हैं और उस स्ट्रक्चर में वो एक दूसरे को मैसेजेस भेजते हैं और मैसेजेस रिसीव करते हैं, इस कॉन्सेप्ट को हम कोलैबोरेशन डायग्राम के अंदर कैप्चर करते हैं। और अगेन दिस इज़ आल्सो अ वेरी इम्पॉर्टेंट पार्ट ऑफ कैप्चरिंग द डायनामिक मॉडल। ग्राफिकली इसको कैसे शो करते हैं? ग्राफिकली एक कोलैबोरेशन डायग्राम इज़ ए कलेक्शन ऑफ वर्टिसेस एंड आर्क्स। अब हम बात करते हैं थोड़ी सी कि इंटरैक्शन डायग्राम्स को डेवलप करने के लिए क्या गाइडलाइंस हैं, क्या हिंट्स हैं जिनको हम यूज़ कर सकते हैं। And then I'll show you when we discuss the banking study to how to actually draw these diagrams and what benefit can be gained out of these diagrams. पहली बात तो ये है कि we need to assign a good name to each part of the diagram. यानी कि चाहे वो vertex हो, चाहे वो arc हो, चाहे वो table हो, x axis हो, y axis हो, message का नाम हो. And so we need to find a good name, a name that communicates the purpose of that structure. And I think we have talked about this previously also, that assigning good names to different structures, whether they are objects or whether they are messages, whether they are processes, is very important, because there is a level of understanding, conveys understanding, and it has semantics attached to it. Second is that you need to use sequence diagrams if you want to emphasize the time ordering of messages. तो अगर आपने टाइम ऑर्डरिंग को इम्पोर्टेंस देनी है तो सीक्वेंस डायग्राम यूज़ करें। अगर आपने ऑर्गेनाइजेशन ऑफ ऑब्जेक्ट्स इन्वॉल्व इन द इंटरैक्शन को एम्फसाइज करना है तो फिर आप कोलैबोरेशन डायग्राम्स यूज़ करें। बेसिकली जैसे कि मैंने बताया था कि कोलैबोरेशन डायग्राम्स और सीक्वेंस डायग्राम्स जो हैं वो एक ही कॉन्सेप्ट को कन्वे कर रहे हैं, लेकिन उनके जो पर्पसेस हैं वो थोड़े से मुख्तलिफ हैं। Another mundane advice is that when you're drawing the diagrams, you need to lay out its elements, whether they are objects or whether they are sequence diagrams. You need to lay out the elements so that the lines that cross each other are at minimal. And so it becomes easy for the reader of the diagram to understand what's being conveyed. Also, for the same purpose, that is to increase the understandability of the diagram, you need to use notes and color as visual cues to draw attention to important features of your diagram. So these things are basically hints and tips on how you need to draw these interaction diagrams. So you need to appropriately select which interaction diagram you're going to use, and then apply the basic drawing skills to draw. Although UML has a very specific notation, but you need to add clarity to it. Now we will talk about application of the banking case study And we'll use these diagrams, both the collaboration and the sequence diagrams, to model the dynamic aspects of the banking case study. So as you can see on the screen, that a collaboration diagram for the ATM client validate PIN use case has been drawn here. Again, to refresh your memory, I would refer you back to the discussion on use cases for the banking case study, and also to the last lecture in which we had applied the concept of state charts to the same domain, and we had drawn state charts for the validate PIN use case. But here you can see the collaboration diagram. So when we are talking about collaboration diagrams, remember that we talk about a society of objects communicating with each other. The purpose is to show the organization of elements in that society. You can see that there's a card reader object, and then there's a card reader interface object, and then there's an ATM card object, customer interface object, ATM transaction object, ATM control object, and the bank server object. For the use case, we also see that actor there, the stick figure, that's the UML notation for an actor. So the first thing in this use case that happens is that a customer walks up to an ATM machine and inserts a card into the card reader, and the card reader then reads that card and sends the information, the card reader input, to the card reader interface object. Card reader interface object is the software object which is modeling the external I/O device in our system. The card reader interface then sends that card input data to the ATM card, which is again an embodiment of an entity of ATM card in our software system. The card reader interface also sends a message to the ATM control which says card inserted. Remember that when we talked about state charts, we modeled the ATM control aspects of it, and you can relate that to this collaboration diagram also, because it appears in that diagram also. And then the ATM control sends a get PIN message to the customer interface. And so you can see that the objects are collaborating with each other to get something done, and that something is a use case, in particular the validate PIN use case for this application. And then the customer interface provides a prompt to the PIN to enter the PIN to the customer, and customer sends or enters the PIN correctly, and then that customer interface sends a message to ATM card with the card request, and the transaction is updated. You can see that customer info message is being sent to the ATM transaction, and the ATM card then sends the card data to the customer interface. And then this process continues, and the customer interface sends PIN entered message to the ATM control. And since we have already talked about state charts, you can see that the ATM control is that state dependent object, and we talked about the modeling of that state chart in the last lecture. These messages appear in the state chart for the ATM control, both for the overall system and also for the use case that we are discussing right now. Now, when this message is sent, the validate PIN message is then sent to the bank server. The bank server is outside the scope of this particular application, and we consider that once a message has been sent, it will continue to process the request and either approve it or not approve it. But in this case, we consider the flow of control, the regular flow of control, and we see that message valid PIN has been sent back, that the PIN has been validated by the bank server, and this message comes into the ATM control, which then sends a message to the ATM transaction to update the transaction, and also to the customer interface, where it basically tells the customer to select the transaction that it is going to perform. And if you notice that the customer interface object sends a message to the actor, which is shown here, which is the ATM customer, and that contains the selection menu. Now this use case, which is the validate pin use case, basically captures the flow of events in a normal course of action where a valid card has been inserted, where the pin has been validated, and this process is necessary for performing all the three transactions that the ATM system can do as part of its functionality. So if you compare this diagram with the state chart that we had developed previously in the last lecture for the same use case, for the same functionality, you can see that this diagram captures the collaboration of objects participating in the validate pin use case, while the state chart captures the states that the ATM control object changes or transitions during the execution of this use case. So there is a difference. There are a lot more detail in this diagram as compared to the state chart, because state chart is fundamentally documenting the different states that one object goes through while a use case is being implemented. And so we were comparing the two different aspects of dynamic behavior. One was captured in the state charts and the other was captured in the collaboration diagrams of the same use case. And so there is quite a bit of distinction and differences between the different aspects that are captured by the two approaches or two viewpoints. State charts capture the states that one object goes through while the use case is being executed. On the other hand, the collaboration diagram captures the collaboration or the organization of objects that exist to implement that use case. And now we will see the sequence diagrams and how they play their part in capturing the dynamic behavior of one use case. Now you can see the sequence diagram of the same use case, that is the validate pin use case, and this complete sequence diagram is shown on three different charts, because if I would have added them on the same chart, it would have made this diagram very difficult to understand. So in the first diagram, you can see that all the objects that are participating in the collaboration diagram are also present here on the top, and on the vertical side you can see that there's a bar which is the timing bar, and the initial messages are shown first, and then as you proceed across the time bar we see the sequence of messages. So the first message that is initiated is card reader input, and that comes from the ATM customer, and that message is sent to the card reader interface object. The card reader interface object then sends one message to ATM card, as you can see on the screen, and the second message is sent to ATM control, which says, and that is a control message, and that says that a card has been inserted into the card reader. The ATM control then sends a message to the customer interface object to get the PIN for that customer. And as you can see that the customer interface object sends a message back to the ATM customer, and you can see that the direction of the flow of event has changed towards the ATM customer. That's the arc here. The message is titled PIN prompt, that is, a customer has been asked to provide the personal identification number of the customer. Now if we compare this with the collaboration diagram or with the sequence diagram, we see clearly that the emphasis on this diagram is more on the sequence of messages with respect to time as compared to the organization of objects or capturing the state of one particular object. So all three of these diagrams have their own importance in modeling the dynamic behavior of a system. The state charts have their own importance, the collaboration diagrams have their own importance, and the sequence diagrams have their own importance. Now, as you can see that the objects remain the same and the timeline continues to grow. ATM customer provides a PIN input, and then that is sent to the customer interface object. The customer interface object then sends a card request to ATM card, which responds with a message titled card data. In other words, the ATM interface sends a message to the ATM card that I need information or data about this particular card, which is then provided to the customer interface object. And as you can see, the direction of arrows will tell you the flow of information in this diagram. The next message that goes out is from the customer interface object to the ATM transaction. This message basically fills up the ATM transaction object, or you can say that at that time ATM transaction object is being created with the information that we have received so far, and then that transaction will be continued to be updated as the transaction is selected and as the functionality of the use case proceeds, and also as this use case is then called by other concrete use cases, then this transaction continues to be updated throughout the execution of the use cases. Since there is no return message or response expected from the ATM transaction, the customer interface object sends a message to the ATM control that a PIN has been entered and it can proceed with the validation. And that's exactly what happens in the next step, that the ATM control object sends a message to the bank server to validate PIN, and the message is titled validate PIN. The bank server, again, I would like to repeat, that is not part of the ATM system or banking system that we are modeling at this time, and it is assumed that the bank server will provide us with a valid or an invalid PIN message. And since we are only at this time capturing the regular flow of events in this use case, we will ignore the alternative path and will only take up the regular path. And that's exactly what happens as the bank server provides us with a valid PIN message, and this message is received by our control object we are talking about for the validate PIN use case. Now we move on to the third part of the same diagram, I would say, which captures the sequence of events from further on. Now, once the ATM control receives a message from the bank server that the PIN is valid, the ATM control sends a message to the customer interface so that the customer interface object can display a message to the customer that the PIN has been validated. And also another message will be sent by the customer interface object, but we'll talk about that in a little while. Let's just finish off this ATM control object, and the next message that is sent by the ATM control object is to the ATM transaction. And the title given to that message is update status. What type of status can be sent? What type of update can be done in the ATM transaction? The very obvious status that can change is that this transaction has a valid card and a valid PIN. So in other words, then the transaction can continue and the customer can then select either one of the three transactions that are possible at the ATMs that we are talking about. So once that message is sent to the ATM transaction, and you can see that on your charts, that and there is no response expected back from the ATM transaction object. The customer interface object then sends a message to the ATM customer, and it provides the ATM customer with a selection menu. The selection menu primarily consists of 3 items. Number 1 is the withdrawal option. Number 2 is the query account option. And number 3 is the transfer funds option. And then from there on, the customer can select either one of them or cancel for that matter and take the card and leave. But normal procedure, one customer would like to perform a transaction of one of the 3 types. Now, the reason we have abstracted away this validate PIN process or validate PIN functionality into a separate use case is because this activity or this functionality is carried out in all the 3 transactions, whether one wants to do a withdrawal of funds activity, or one wants to just query an account, or to transfer funds electronically between 2 accounts. And so when we were talking about use cases and organizing use cases, we found this to be a piece of functionality which can be abstracted away into one use case and can be used into other use cases. So comparing the sequence diagram with the collaboration diagram and the state chart of the same use case, we can see that each one of them, each diagram has its own importance, and each one of them captures a very important viewpoint in modeling the dynamic behavior of a use case and eventually of this entire system. Now, one thing that I would like to say again is that it is not necessary to use all 3 of them in all situations. The need for each one of them varies, and depending on the application domain and depending on the need for the and then the availability of time, one has to decide which diagrams must be used to capture the dynamic behavior of the system. Now we'll take up another use case, that is the withdraw funds use case. You have already seen the state chart for that, and we'll briefly go over the collaboration diagram as well as the sequence diagram for the same use case, so that you can have a further deeper understanding of these 2 forms of interaction diagrams, as well as you can have a better comparison with the state charts. And so you can see the collaboration diagram for the ATM client withdraw funds use case. In this use case, you have the card reader interface, the ATM control, bank server, you have the cash dispenser interface, you have the actual cash dispenser object, you have the ATM cash object, and then you have the customer interface object, ATM transaction object, and receipt printer interface, and the actual receipt printer. Because since we have to show the collaboration among different objects, it is necessary to show them all on the diagram. And you can see that this process, that is this use case, actually starts by the selection of the customer on when the customer says that yes, I want to do a withdrawal transaction, a withdrawal funds transaction, and then the customer provides the necessary transaction information, and that necessary information is sent to the bank server for approval to check if there are enough funds available, and to check that this and the maximum daily limit has not exceeded, and if the customer gets an approval then the ATM dispenses the cash, and before it dispenses the cash, the ATM checks if enough cash is available in the ATM to be given to the customer. And while all of this is being done, the bank server is then sent a message to update the accounts. And also, if the cash is dispensed, the ATM cash object, which keeps information about the actual amount available at the ATM, is updated to reflect the fact that so much money has been given to the customer, and that is obviously subtracted from the running total. And then at the end of the transaction, the receipt is printed, and the information contained in the receipt is obtained from the ATM transaction, and the card is ejected, and then the ATM becomes available for the next transaction. So this is the sum total or sum story that goes on the collaboration of different objects to perform this particular very important use case. And comparing again with the state chart that we talked about in the last lecture, we can see the differences between the emphasis on being on the society of objects in the collaboration diagrams and the organization of objects in the collaboration of diagrams, as compared to modeling of the state dependent object, which is the ATM control object in our particular case. Now we can see that the sequence diagram for ATM client withdraw funds use case, and again this is shown on more than one chart to clarify and to pictorially show you and communicate to you the sequence of events that happens, in particular relation to the ordering of events, that is the time ordering of events to complete this use case. The number of objects or the objects that participate in a sequence diagram are the same, same as the ones which contribute or which participate in the collaboration diagrams, and they are card reader interface, ATM control object, then there is the customer interface object, the ATM transaction object, cash dispenser interface, ATM cash object, receipt printer interface object, and the bank server object. And this sequence starts with an ATM customer making a selection on the withdrawal, and then that selection is sent, selection input, to the customer interface object, which sends one message to the customer transaction consisting of the customer selection, so that the transaction can update its data, and the ATM transaction then sends the transaction details to the ATM customer interface. These details will now be sent to the bank server for approvals. But before that is done, the customer interface object sends a message to the ATM control which says withdrawal selected, and the ATM control sends a message to the bank that withdrawal has been requested. And all the withdrawal details are obviously sent again. The customer interface object is also sent a message by the ATM control, and that message is basically a wait message, a display wait type of message that can be implemented by showing an hourglass type of thing, in which the message is that transaction is being processed and you have to wait until the approval. And in the meantime, when the bank approves the transaction, an approval, a withdrawal OK message comes from the bank into the ATM control object, which then instructs the cash dispenser interface object to dispense the cash, and it also informs the ATM transaction object to update its status, and that status would obviously mean that the transaction has been approved and the cash has been dispensed. The cash dispenser interface sends a message containing the amount of money that was requested for withdrawal to check if that much money is available or not, and it responds with the cash response, whether saying it yes it is available or no it is not available, and then that is shown to the ATM customer. And also the cash dispenser interface dispenses the cash and sends a message to the ATM control that cash has been dispensed, which then sends a message to the display to the customer interface that the cash has been dispensed, and customer can collect that money from the cash dispenser. And a message is sent to the bank server to acknowledge the fact so that the cash has been dispensed. And this is important because the accounts are maintained at the bank server and they are not maintained at the ATMs. And so the bank server need to update the accounts of the customer accordingly. Then a message is sent by the customer interface to get an acknowledgement from the customer that the cash has been dispensed. A transaction request is sent from the printer interface, because that at the end of it the receipt has to be printed, and that data is available at the ATM transaction, and this data is then sent to ATM's receipt printer, which prints a receipt, and that receipt is made available to the customer. The receipt printer then sends a control message to the ATM control saying that the receipt has been printed, and ATM control sends a message to the card reader interface to eject the card, which basically ejects the card and is received by the customer, and the card reader interface responds back to the ATM control that the card has been ejected, and a message is displayed by the customer interface object to the effect that the transaction has been completed and the card has been ejected. And so this is the sequence diagram for the withdraw funds use case, and you can now compare these three diagrams. One, the state chart diagram, the second is the collaboration diagram, and third is the sequence diagram for the withdraw funds use case. And you can see the different aspects of the dynamic behavior that are captured in each one of these use cases. So with this, we have talked about two use cases, one being the validate PIN use case, and other is the withdraw funds use case, and we have looked at them from three different perspectives, from three different tools or three different modeling techniques to capture the dynamic behavior. We have applied the state charts to them, we have applied the collaboration diagrams on them, we have also applied the sequence diagrams on these two use cases, and they basically are a very useful tool to completely model the dynamic behavior of the use cases. The other two use cases, which are the query account use case and transfer funds use cases, you can apply your knowledge and you can apply your skills to develop both kinds of interaction diagrams, that are the collaboration diagrams as well as the sequence diagrams, and that exercise will help you in understanding the dynamic behavior that exists for those use cases also. Now we will talk about a consolidated collaboration diagram for the ATM client subsystem, and I'll basically list out the objects that participate in this collaboration and talk about a few things before we end this lecture today. The objects that participate in the collaboration for the ATM client subsystem are card reader interface, ATM card, customer interface object, ATM transaction object, ATM control object, cash dispenser interface object, the ATM cash object, and the operator interface object, and the receipt printer interface object. I would also like to mention that for this particular subsystem, the external objects that exist are the card reader, which is the physical I/O device, the actual device that reads the card. Then this is the bank server, which is in itself a subsystem, and which we are not modeling for this exercise. Then there is this cash dispenser, the hardware I/O device. Then we have the receipt printer, which is also an external I/O device. And finally, we have the ATM customer, who is the person responsible for performing these transactions and who benefits from these transactions and can use either of the three transactions that we have talked about. Each of these external devices or users have an equivalent interface object in our system. We don't need an equivalent interface object for the bank because that is a software system and we really don't need to have a separate interface object assigned to it. But these objects that you see on the screen are collaborating with each other to model the dynamic aspect of the ATM client system. And these collaborations show the organization of objects in our ATM client subsystem. And there is no need to develop a sequence diagram for the ATM client subsystem. And so this, the last diagram that I've shown you, basically captures the collaboration or the organization of different objects that exist to perform the activities of the subsystem that we are modeling. In our case, this is the ATM client subsystem. Now, up till this point, we had 3 lectures devoted on the dynamic modeling and capturing the dynamic behavior of a system. And we have talked in detail about the state charts, the finite state machines, the state transition diagrams, and how they can be applied to a particular real-time system. What is the importance of each of these modeling techniques. We have also talked about interaction diagrams. We have talked about 2 specialized versions of interaction diagrams, the collaboration diagrams and the sequence diagrams and their importance. And we've also applied them to the banking case study. Now, if we carefully analyze that we have covered all the important aspects of modeling as it relates to the software requirements. We have applied the use case modeling techniques to the banking case study. We've applied the static modeling techniques as far as object modeling is concerned to these techniques. To the banking application, we have applied functional modeling techniques to the banking case study, and we in fact have done 2 functional modeling techniques, both the real-time structured analysis as well as the structured analysis and designed SADT techniques to the banking case study. And then we took up the dynamic modeling and we applied the state charts to this application domain, and today we applied the collaboration and sequence diagrams to the banking case study. And so in other words, we can say that we analyzed the application domain from different perspectives, and we have sort of tried to uncover all possible problems and all possible aspects that exist in this application domain for understanding this application domain. And so what we will do in the next lecture is we will formally try to document the requirements of this application domain, and after that we will move on to more interesting and specialized topics in requirements engineering. So I take leave of you and I'll see you in the next lecture. Thank you.